Graphing quadratic, right? This is something you haven't seen yet, right, Echo? So you might want to take good notes on this because this is how I teach graphing a quadratic. I have a thing called 4-step method plus 1 because I have another thing called 5-step method. So the first step is finding the derivative. And so this and setting the derivative equal to 0. So the derivative is can also be looked at as 2ax plus b, whereas you have, sorry about that, ax squared plus bx plus c is your quadratic, of course, right? Your derivative is technically just the exponent times the coefficient, right? And then you take 1 away from the exponent. So this would be 2/3 x. And then there's actually a 1 here. So minus 4/3. And then you set that equal to 0, right? This is not a fun problem. Obviously, this should be more of a pre-calc problem. I typically would have made this a non-fractional problem. For some reason, the computer misunderstood me. So I'll have to look at that maybe and change the parameters of this problem. But it's not. I mean, it's not that bad. It's just dealing with fractions, so you should be able to do it. I'm going to add 4/3. Add 4/3. So I got 2/3 x equals 4/3, right? And then I'm going to multiply by 3/2. And I'm going to multiply by 3/2. These cancel, leaves me with x, right? Am I recording? Okay, good. And then, well, these cancel. That's nice. And 2 goes into 4. Well, that's twice. So actually, maybe it did listen to me because the number we got was nice. Just looks hard, right? I could have never come up with that in my head. Well, I could have. I would have struggled. Then we just take that, and that's our second step. And our second step is, I used to call it plug it in, because there was a commercial. Plug it in. Way long time ago when I first created this thing. So all we're really doing is doing the F. I found that it was better to just show students that I'm plugging in the F of the axis. So we know this is your axis of symmetry, right? And that's what it asks for. It says, identify the vertex, the axis of symmetry. So we have the axis of symmetry, right? And to find the vertex, we've got to plug in the axis, right? And that gives us our vertex. So all we got to do is take this y, which is really f of x, right? And plug in the x. So I got 1/3 x squared minus 4/3 x, right? Plus 10/3, right? And so what I do is I plug in that 2 and that 2. And in this case, I have 2 squared, which is 4/3. In this case, it becomes minus 8/3. Now these should always be halves of each other. You know you're on the right track if you get halves. And we are on the right track because this is half of this, right? So then I take this away from that and I get, hey, negative 4/3 and plus 10/3. And because they're all in thirds, this is really easy. So f of 2 is equal to 6/3. And what is 6/3? 2, yeah. So f of 2 2 is equal to 2. And so what we get there is a vertex. And the vertex is, well, I'll just put it down here. 2 and 2. And I'm going to write that 2 kind of like that too, so you see the difference of the 2's. Right? This 2's coming from that one. This 2's coming from that one. And that's your vertex. 18. Now they want you to graph it. Hardest part. I just say quit. Let's just quit. It's the hardest part. We don't want to do this part. Can't. We'll never make it. Right? Bunch of Eeyores. Yeah. We can never do it. Alright, so part 3, right, is finding f of 0. I'm sorry. Just say, head's going again. Alright, so, thinking about Easter. So we've got f of 0 is always equal to c. If you take a look at this equation, if I plug in 0 for x, they go away. And so I'm left with just c every time. Makes it really nice. So f of 0 is equal to c, which is 10 over 3. Right? It's kind of a nasty number, but it's not that bad. So I got 0 and 3 goes into there 3 times 1 left over. So that's my point of symmetry is what I like to call it. Okay? It gives me a point on the axis. So the one thing is I got 2 and 2, and I got 0 and 3 and a third, right? So I can start graphing that pretty easily. So 1, 2, 1, 2, and that's 2 and 2, right? That's your vertex. We know it's smiling, well, because this is positive. That first letter, that first number is positive. So we're smiling up, and when we graph this point, it goes to 3 and a third. So just think of it as a third way to 4. That's all. Not a big deal. We're going to come up right on through here. And now we need to graph that other side. The other side is the fourth step. The fourth step is pretty simple. It's just f of 2 times the axis. Okay? If you remember that, we're just plugging in twice the axis. That's it, every single time. And it should equal c. But this is our check method, right? This, if it works, we know, just like if this is a half, right? If this turns into the opposite sign of the first one, woo, we're doing it right, right? Same thing here. If this turns into C, woo, we're doing it right, okay? So I call it the check method. And so I plug in, it's not as easy as plugging in 0. I plug in 2 times the axis. The axis in this case is, well, it's a 2. Okay? So when I plug that in, I get 1/3 times x. Let me remove that. So I'm plugging in f of 2 times 2. Right? So technically I'm plugging in f of 4, right, into 1/3 x squared minus 4/3 x plus 10 over 3, right? And in this case I'm plugging in a 4 and a 4, right? And then when I take this 4 and I square it, I get 16. So I get 16/3. Well, that's a nasty number. But what's cool is I get minus 16/3, and that's okay because they just cancel. So what am I left with? The number, right? So I come back and I have 4 and 3 and 1/3, and I'm good to go. That's my other point of symmetry. So I'm going to do that at 4. So that's 1, 2, 3, 4, go up to that point, and bam, there I go. It's a beautiful picture. Thank you very much. I'm here all week. Well, you know, it's already Wednesday. Okay.